Hi, I'm Brian Myers, Senior Project Manager for Dayton Audio. Today, I'm here to talk about the DATS Loudspeaker Analyzer, or DATS LA, and how to derive small signal and large signal parameters. To do this, you will need to have the DATS LA calibrated. But since you only need to do that once, you're probably already there. We need to connect the driver. Be sure to have the polarity correct. Once we connect the driver, we're ready to do our testing. If your driver under test has venting in the back, you need to elevate it to let it breathe because it will affect the parameters. I like to use a poster tack or a sticky tack. We have some available from Dayton Audio along with the precision scale to do delta mass measurements. Let's begin. If you go over here to the left-hand side, midway, there's measure free air parameters. We click, and you're going to hear a low-level sweep. Okay, actually, you can look down here, Z sweep amplitude is -10 dBu. Okay, and over here on the right-hand side, you can see we have about half the list of parameters. They're all electronical parameters. We really need to get the mechanical or MK parameters to get a full list, parameter list. I like to use what's called the added mass method or delta mass. So I click on that. I accurately measure. I like to use a poster tack. The sticky tacky works well. And we place it on the accurate scale, and it looks like it's 44.4 grams. So we go 44.4 there. And it also needs the actual diameter, the apex of the surround and across to the apex of the other side. And it appears to be exactly 105 millimeters. Place 105 millimeter here. And then we say measure VAS. It's going to say, oh, add mass to the driver. I forgot to add the mass. So what I do is I like to use this sticky substance because it needs to stick firmly to the cone. I reach underneath and I kind of press it on there to make sure it's secure. So I added the mass and say, okay. Now you hear another low-level sweep. And now you have the parameters, a full list of parameters on the right-hand side. And that's your small signal parameters. We're going to actually save them. Go to the view, save to memory. Let's save it to memory 1. Now, we can use the same process to do large signal parameters. What you need to do is down here on that Z sweep amplitude, let's go to +10 dBu. This driver, that's pretty large signal. Okay, now we do the same procedure, measure free air parameters. If you notice, a lot louder sweep, and you have your half your parameters, your electronical parameters. So we're going to do the same delta mass, added mass method. So we know it's 105. And we know it was 44.2 grams. And we say measure VAS. And again, it's going to say, hey, you need to add mass to the driver. So what we're going to do now, since it's so much louder and so much more cone movement, I really need to make sure this is secure. So I'm reaching under without damaging the driver. I'm just reaching under, making sure that this mass is uniformly distributed and secure on the cone. So we add a mass, and I say, okay. Now you have a full parameter list on the right-hand side. Let's save that to, let's save that to memory 2. And if you notice, large signal parameters are different than small signal parameters. Small signal is useful, but large signal parameters is becoming more popular because of high-powered drivers. Well, that's how you do it. That's how you get large signal and small signal parameters. Hope this helps, and I'll see you in the next video.